Hi, everybody. My name is Emily Wilson, and I am here from the University of Connecticut Center for Land Use Education and Research and CLEAR. And we are happy to be kicking off our geospatial webinar series today. This series is in partnership with the Connecticut GIS Office, or which we have two folks here today from the office, and which we're happy about. I think they'll talk more about that in a minute. This series will be scheduled on Thursdays at 1 p.m. Some Thursdays, not every Thursday, every few Thursdays. Um, we are updating the webpage, which you can see on the slide as our webinars are scheduled. We currently have on the calendar. First is October 10th, which will be more of an introductory overview kind of webinar and create a foundation for topics coming up. And the next is scheduled for October 24th. That registration is not up yet, but it will be shortly after this presentation. If you have an idea for a webinar topic, please send us an email at that email there. We have some ideas, some very technical specific ideas, some very general overview ideas, but we welcome any suggestions. And there's also a link to a website on this slide, and I believe in the chat now, where you can find more information about upcoming webinars, register for them, and also find the recordings. Yes, this is being recorded and will be posted in a few days. So today's webinar will be in two parts. The first part will be introducing the Connecticut GIS Office and our State Geographic Information Officer, GIO, Alfredo, will be doing that part. And then the second part will be all about image services, and Carl Zimmerman will be doing that part. Throughout the webinar, if you have a question, please type it into the chat. We may be able to answer it in the chat, or we will save it for the speaker after that part. So without taking any more time, I will turn it over to Alfredo to get started.
So, like Emily said, I'm Alfredo Herrera. I'm the Geographic Information Officer at the Office of Policy and Management and for the state of Connecticut. And if you go to the next slide, please. So I will be diving into a little bit of the history of the GIS office. So we were created as part of Public Act 21-2 back in 2021. And following the June special legislative session there. That legislation created the GIS office, the GIO position, placed it within the Office of Policy and Management, or OPM. As a result, we have a certain amount of responsibilities that we are required by statute to fulfill, not least of which is GIS data coordination, the responsibility for managing and publishing open data, supporting economic development throughout the state, performing outreach and training, which is one of the things that we are doing now, collecting and acquiring and coordinating on ortho imagery and elevation data, producing guidance and standards, doing data processing and analytical support for state agencies and others to a lesser degree. And then also we have with another legislation that passed that same year as part of Public Act 21-159, we are also responsible for mapping broadband availability and adoption throughout the state and producing a map at minimum every year on December 1st. To varying degrees, we have been doing these things. And so what I will go through now is the makeup of the GIS office and then some of the examples in which we have been doing these activities. So first and foremost, I'm Alfredo. I am the GIO. With me, we have Carl Zimmerman, who is one of the GIS coordinators. He handles a lot of the training and outreach and just general analytics support. We have Ashley Benitez, who is in charge of broadband mapping and locational services. And then we have two GIS analysts that are just provide a lot of technical support and analytics in production of GIS data and content for us. And those are Leah Hodges and Sarah Hurley. So what are we doing? What kinds of things do we produce? And what opportunities are there to work with us? So first and foremost, we created what we call the CT Geodata portal. This is a ArcGIS hub-based GIS clearinghouse to be that is meant to be in partnership with not only the open data portal, geodata portals, or GIS clearinghouses from other state agencies and other entities such as CLEAR, like CT Eco, but it's meant to also be kind of like the partner platform to the CT Open Data portal, in an effort to kind of create a no wrong door situation, if you will. All of the data that is in the geodata portal automatically gets synchronized to the open data portal. So from that aspect, all of the information can be found on either platform. Um, However, we are being a bit more selective due to some technological restrictions on the flow in the other direction, where some of the tabular data sets are being spatialized and made available through the CT Geodata portal. One of the highlights of the geodata portal is that we kind of federate and integrate data from other agencies and entities. So currently we have federations set up with Connecticut Department of Transportation, the Department of Energy and Environmental Protection, and as well as the CT Eco platform as hosted by CLEAR, primarily for their imagery and elevation data. All of that is available through the Geodata portal, and we have other webinars that we have done in the past that kind of show how to use that platform and get the most out of it. And I think that Carl maybe talk about that in either in this one or in a future webinar. As of now, the Geodata portal has been live for a little over almost 3 years. And we are updating it regularly. We are actually working on some additional publication guidelines and guidance and best practices, as well as in the beginning phases of a redesign to refresh the site and make sure that it looks up to date and stays up to date, and make sure that everything functions the way that it should. And in addition to that, we are also coordinating with other state agencies regularly to make sure that as we come across new data sets, that we include them in the geodata portal and make that data available. So one of the activities, as I mentioned before, is broadband mapping. So we are currently performing the 5th data collection from the internet service providers, and are well into diving in and kind of taking a good analysis of that data and making sure that we understand what's in there. We are playing a little bit of catch up with the last submission that we missed because of a staff vacancy, but now we are caught back up, and we expect to get the 6th submission, which corresponds with the most recent FCC submission here in the next few weeks. And to that end, we will be producing updated maps no later than December 1st, as required of us by the statute. The next thing I'd like to highlight is an interaction with another state agency, and this in particular is the Department of Economic and Community Development, or DECD, in particular their State Historic Preservation Office. So they had a very giant program to digitize historic and archaeological documents and sites and make it into a GIS layer. So we assisted them in kind of creating the final version of the web interface for both the public and the restricted viewers that they are currently using. And then all of that is also federated through the Geodata portal. So that is a very valuable resource that you can do if you do such work or are involved in such things. One of the things that I will say, if you do need access to the restricted viewer and you're one of the people who SHPO has identified as being allowed to use it, please by all means visit the conchris.ct.gov website to request access. And there's a survey there that just you fill out your information and you can request access if you need it. Next, I would say statewide parcels is another big important milestone for the GIS office. So last year we have so OPM has been collecting this data since about 2021, 2019 or so. And last year in 2023 was the first time that we actually integrated it into a single seamless data set. It has about 1.247 million parcels in it, with about 37 fields worth of assessor's data attribution in it. As you can imagine, this makes it an incredibly powerful data set, and incredibly important for many, many activities, from, very, very simple, just like where am I, what is one property, and all of those things, to things as dynamic as like understanding vacancy rates and land use and occupancies and valuations and tax incidence reports and things like that. So, there's a lot of data to mine there. It's an incredibly powerful data set, which we will be talking about later in October in greater detail. And one of the updates that I would like to give on this particular data set is that the 2024 data submission process is largely complete. We are well into processing the data and integrating it into an updated version of the seamless data set, which is, once again, this data set just keeps getting better and better and better. And where anecdotally, one of the things I will say, last year it took us about 8 months to synthesize the seamless statewide data set. This year we are on track to do it in about 8 to 9 weeks as opposed to 8 months. So as we make process improvements to the collection process, and as we understand how to piece this data together, the data is not only going to get better, but it's also going to be available sooner. And with that, we also kind of leverage that data set to make a very simple parcel viewer, so that people can kind of look up parcels in any town, do queries, use the data set in whatever way they see fit. Once again, there's no shortage of ways in which you could use this data, and we will definitely be talking more about it in October 24th in that webinar. We are also working on statewide addressing to make sure that we identify where all of the addresses in Connecticut are. We are working in conjunction with the DESP, so the Department of Emergency Services and Public Protection. I think that's the acronym. To make sure that we have as complete and as accurate a address data set, so that not just emergency services, but also the people that need to use that data set for geocoding have the most accurate information and are not having to rely on proprietary licensed products as much, and can have something that they can rely on to be accurate and reliable. To that end, we were constantly improving that process, and further efforts on this topic are ongoing. Broadband. So as I mentioned before, we are doing a lot of things with broadband mapping. We do have a statutory requirement to update mapping. We have, as I said before, we have completed the ISP submissions for the 2024 for the time that we lapsed. We're about to receive the data for the current submission, and we will be processing that in time for the December 1st map. We have also purchased additional data sets from a licensed vendor to kind of understand, okay, well, what are the speeds that people are reporting, and we're using that as a really good tool for ground truthing what we receive from the ISPs. And as always, we're comparing this to federal data, and then we are also using it to assist our partner agencies in evaluating the how best to distribute funds that they have from the federal government to basically just improve the state of broadband. So that brings me to the end of my portion of the presentation, and I'm happy to take any questions that may be in the chat.
Thanks, Alfredo. We don't have any questions in the chat yet. If you do have a question, please type it in there. Okay, there is one question here. What are the anticipated scales for the published mapping?
Um, I guess a little bit of clarification on that. What do you mean by scales in terms of, like, is it like, are you talking like mapping scales like 1 to 24,000? So these are meant to be, um, if that's kind of what you're referring to, the the scales are whatever precision that we get with the data in particular. So the towns are responsible for digitizing the data per surveys and maintaining the parcel data sets in particular. With the in terms of the broadband stuff, these are done at the census block level for the availability data and the census tract level for the adoption data. And that is due to that data status as trade secret from the ISPs. We have negotiated and agreed to release that data at those scales. In terms of the SHPO data, that is as accurate as you can get with a GPS. So it's usually within, at most, a meter, at best, a few centimeters. It varies on the different data type, but we usually do our best to let the data be as accurate as it can be, and then we the end users kind of like use that at whatever scale they need to use. um Carl will talk about in a few minutes about a portion that is much more scale dependent, but in terms of that data, I think you will be pleasantly surprised that that will be much higher resolution than one would be expecting. Uh,
Uh,
see.
Thanks, Mike. If that, hopefully that answered it. If not, we can at the end bring this back up and talk about it. One more question here came in. Are the parcel town boundaries still being reviewed and corrections being discussed?
Yeah, so we have multiple avenues on this. So we are working with Department of Transportation Survey Division to kind of grab as many surveys of town boundaries as we can, and we are going to be issuing kind of parcel drafting best practices and guidelines very soon here near the end of the year, that will help kind of articulate what one should and shouldn't do with that particular aspect of parcel digitization. And then also coming in January, we are planning to start up a working group to kind of develop a more formal and complete parcel standard, and that will most definitely be a part of it. But to kind of bring it, kind of distill it down to say the short answer, we are taking surveys and we are actively working on making sure that the boundary information that we do have is as accurate as possible and as based in survey as possible. And there is some work to be done still to before we can call it truly authoritative, but that is the goal, is to kind of get it to the point where everyone can be in agreement that this is as accurate as it can be for GIS.
Thank you. And we have
Uh,
one follow up on that. Sorry, Carl, one more here. How old are the surveys of town boundaries in Connecticut?
that varies by area. So some areas are surveyed very frequently, and some surveys have been done within the last couple of years. And then others are much, much, much older. In fact, I was commiserating with my counterpart from Rhode Island and saying that many of the monuments between the Connecticut and Rhode Island have gone missing and are now either mantle piece or either fireplace mantles or steps to somebody's backyard. So there is some work to be done there in some areas, but it is kind of a mixed bag, if you will, of kind of pretty recent and accurate versus very, very old and to be updated. But that is the nature of such work, and then we are working to improve it and get to a point of kind of common understanding.
And here's a question, will data be available as shape files?
Yes, so the ArcGIS Hub platform lets you download in a variety of different formats. So shape files are definitely an option, as are, I believe, KMLs, KMZs, and file geodatabases, as well as just a REST endpoint if you are capable of dealing with an API URL. So there are a lot of different options. If there's something that we haven't been able to cover or do, please feel free to reach out and we will do our best to accommodate.
And will there eventually be a universal parcel ID system statewide?
That is a thing that we have explored. It would definitely solve a lot of problems, but I think that is, I would say that that is definitely for that eventual work group to kind of determine and develop.
And can I add something? That might, if stakeholders are interested, that is, the people of Connecticut are interested in that, then you should speak up and talk to your local government or state official, because it really needs to be a ground, from the ground up as opposed to top down.
Agreed.
Okay, thank you, Alfredo. With that, we'll turn it over to Carl for the second part, and we will have time for questions and answers after that as well.
Okay, Emily, can you see the part 2 screen
Yep, we can see
slide?
your side. Looks good.
Okay. Hi, everyone. Carl here. I'm going to be talking about the imagery services, and we have Emily on this webinar as well. And Emily has been tightly involved in this for multiple generations of data. So, congratulations to Emily to getting services available, and the whole CT Eco website that is really the rock of the backbone of Connecticut GIS data. So we appreciate your help with that, Emily, and continued support. Okay, so I'm going to be talking about a little bit of technical issues, something about how to get the imagery, and then a few items on the tools available. And I will mention that I will be talking both about tools you can buy and tools that are free, because I want to make sure that people understand there are free options, but we'll get to that in a few minutes. Okay, so what is the consequence of our imagery acquisition program? And we're midway through it. We've completed the 2023 acquisition, and we're now doing the planning for 2026. This was funded by ARPA funding and is part of our requirements by state law. We had a vendor selected. They flew the imagery and LiDAR. We went through a very laborious QA/QC process, and probably many of you on this helped with that. So we had both a vendor-based QA process. We had our stakeholders and users participate with us. We did it internally, and we're now getting the fruits of those labors, which is we're getting data back. So currently we have the imagery. It's still in beta. It's still called Beta Plus. It's moving along, getting closer to the final version. Emily is working on processing the latest and greatest update. We have a whole litany of products, which I'll show you, but a couple important things to remember. Our LiDAR, which is the point cloud that is generated, was very high quality. It's 15 to 20 points per meter, which was very unusual at the state level to get. We also have a building footprint, 1.9 million buildings that are being produced, and 3D versions of those, which will be used for planning and demonstration purposes. And then we have the DEM, which is going to be the next big item that'll come after this. We don't have the DEM yet, but it will be coming. I just talked to the vendor. It's expected to arrive at the end of the month, and then we'll get it up as soon as possible afterwards as a beta service. Okay, so this data was built under the specifications of ASPRS. And if you don't know about the importance of specification, I just want to reiterate it. Whenever you get a geospatial product, you should have pointing to a set of guidelines and rules. That's what the specification is. We use ASPRS, which is a globally known for our imagery. Now, the imagery is 4-band. That is, we have what they call RGB, which is your natural color, the things that when you look at the screen, you see things that you expect to see, like green trees and green grass and brown buildings. And we have near infrared. Infrared is this band that is invisible to the eye. Some animals can see into it, but it does, what you do is you take what's invisible and then you put it into an invisible, what they call channel in the screen, so you can see what couldn't be seen. And it's used extensively in environmental applications, finding water and other methods. So we have both RGB and near infrared. And then as part of these specifications, the imagery should be snow-free. The sun angle is 35 degrees or less, which means it's like this. Distortion and smudge-free. In addition, we received true ortho for I think 66 spots in the state, mostly bridges and downtowns. And I'll show you an example of that in the middle. But basically, what it does is make sure that buildings and bridges in those positions are vertical, purely vertical, with no oblique distortion. The data was delivered in this order, from the northwest to the east, and this was done as the vendor picked up and corrected errors. So the northwest has very few big cities, as you know, so we started with that. Blocks 2 and 3 were much more populated, so they had hundreds of thousands of buildings and other features that had to be QA'd, and the fourth was mostly imagery and LiDAR, because it is much more rural in the east side of the state. Okay, here's some examples of the imagery we now have available in the services. Here on the left you have Bradley. In the middle we have New London and the submarine hub. If you look closely, and we can zoom in, you can actually see submarines in dock, and then an example of the near infrared, where you can see detailed landscape that aren't visible in the normal imagery. And I mentioned this true ortho data set, and this is particularly valuable in places like Stanford and Hartford. On the left, you see the typical image, and you notice that bend in the sail building. You can see the side, and on this side, you can see it's vertical. Note the key thing here is that what was invisible on this side becomes visible on that side, on the true ortho image. Same thing on the bottom here. You see the building lean here, and then you can see within the streetscape on the right, on the lower right. So this is useful for measurement. That's why DOT likes these. And it's also useful for emergency management purposes, so that you can see around the entirety of a building in a downtown area. So eventually, not yet, but eventually, once we get the last tile back from the vendor, we will have this incorporated into your imagery for the downtown areas and the bridges. The LiDAR is a point cloud, and the point cloud has very exacting elevation and distance information embedded in it. And from that, we make these digital elevation model products. These are very high quality. We're going to have 2-foot pixels, and they include a lot of checked the stream corridors for modeling. So if you look at this middle image on the right, you can see the channel going down, and you see that some have bridges covering and some don't. This is a spec that allows us to do hydrologic modeling, and as part of the check, they check to make sure that there's flow on there. Because if you've ever played with these DMs, sometimes they're things called holes. So in reality, there's always flow, and therefore you can model this correctly in some kind of hydrologic model for stormwater purposes. Here are some additional examples. On the left, you can see these great details of the corridor, the floodplain with the stream coming in. You can see the braiding of the braiding of the stream. On the right, you can see a big park on the Houstonic with the actual grading lines on the lower right. And then you can see in this one, for someone who was a landscape architect and who hand graded and hand contoured things, these are 1-foot contours of parking lots, and you can actually see the flow lines of the water to the drainage and along the edges. And so as civil engineers, if there are any civil engineers or landscape architects in this, you'll be able to actually look at surface water flow in parking lots and urban areas, and probably you've never seen automated before. And then a final derivative product from the LiDAR that I mentioned is the 3D buildings. These are QL1, and sorry, LOD2, not QL, the wrong specification, LOD2. And that means that you have, it's not just a cube, you have roof details, like dormers and air conditioning equipment. So that'll be included as a beta type product for use and evaluation. All right, so that's kind of an introduction to the data that we have. And just a reminder, this data is really, really huge, okay? So we have 2.3 trillion, that's a trillion with the T pixels. We have 177 billion LiDAR points. The raster, which is your DEM, will have 36 million elevation points and 1.9 million buildings. So these are really massive data sets, and how do we deliver them to you? So the old model would have been that you would have gotten a big drive and you would stuck that in your desktop. And if you're lucky, it all fit on the hard drive. And if you weren't lucky, then you'd have multiple hard drives and you switch back and forth. The newer and better model is to use WebGIS. And basically you have a big server someplace, and then you send out the data through the internet, and then it's consumed by your software. The old model, the desktop model, still exists and still being used, and there's a hybrid version of it, which you can grab the web service into your GIS, but most people are using this WebGIS model, which allows for really huge data sets to be delivered efficiently to users. So basically, this is a client-server model, and for those of you who haven't heard of this, basically the client is your computer or your browser. And what the computer does or the browser does is calls the server with the data and says, hey, do you have the data I want? And the server responds with a list of items, that is the geographic data. And then the client then knows what to ask for and then calls the data back, and then it gets shipped over. So you have this kind of interchange that goes back and forth across the internet. They use the standards, which allows it to work quickly and universally. And this gives you a lot of interoperability, which means you easy to exchange data and a lot of speed. And it reduces the burden of the client, that is you, on managing these huge data sets. Again, we're talking 2.3 trillion pixels. What do you do with that? You don't. That's why we have Emily and her service for us. Okay. So kind of a basic definition of web mapping service. This is the academic in me. I like to go back to basic definitions. It's a simple web interface that allows you to request a map image from a GIS. And typically you request an area of interest, which is your little box, and then a data set. And then the data is returned, and then it gets written or displayed on your screen, and then you can use it for your purposes. The web mapping services come to two camps. One is the ESRI world, which is the imagery services, which UConn has a lot of, but they also have the OGC. That's the universal standard for open data. And both of those play a role in different softwares, and a lot of software will consume both. But you should know that there are two different groups and two different standards that you may have to deal with. Okay. So here is a lot more wonky and technical diagram of the same thing. You have the data store or some catalog which functions as your server, and then you have a consumer or client, which is on the other side, which is where you get the data from, and you see it in your browser. And then there's a whole variety of possibilities in the middle. And we'll talk a few about a few of these, but basically, depending on the data type, you may have different services. And then depending on your application at the end, you may consume it in different formats. But basically, it's a fairly seamless path between the client and the consumer on one side and the server on the other, and the complexity is hidden in the software and the service. So just so you know, there are three basic types. There's an image-based map service, which basically, when you make that call from the client, you get a little map image that is put into your GIS in the correct coordinate space. You have a feature-based service. The classic example is getting stuff from DOT, which has geometry to it. That means you can measure and get geographic information from it. And then you have the tile map service, which is the especially fast, scalable version of that. The mapping service is very easy to use in ArcGIS Pro, and I'll show you how to do that. But you basically add your path, and then automatically all your web mapping drops in. There are two versions. There's a dynamic cache version. Right now we have a dynamic version, and the cache version is when everything is pre-built. You have a feature-based version, which is about vector. It gives vector objects back. Here's an example from DOT of bridges, and it gives you locations a lot, not just the little image tiles. Again, people who are engineers and surveyors use this format extensively, or if you have point data. And then finally, you have this tile service. This is the cache version, and basically what it is there are all these different scales from level 1 to level 22. Level 1 basically means you have the whole world in view, and level 22 means you have a little tiny bit of your yard, and so it's each scale. You go up, you get down into finer detail, and so you have for each tile you have 256 pixels, and they're all pre-generated. And so when you make that call to the server, you get the image pre-built and then at the right scale. And it turns out this makes things very fast and much easier than for the network to handle than the map services for zooming up and down and handling large amounts of imagery. So if you go to CT Eco, I mentioned that this is Emily's baby. She's been working on it for many years. You get viewers, you get services, and you get downloads. Downloads you probably don't want to download all these unless you have all these data sets, unless you have specific purposes, like you're want to have a map for a region-wide project. You use services if you want quick and easy access to a variety of data in your application with other, and then the viewers for people who just want to look at the data. Let me quickly. So in the CT Eco site, you have viewers and you have the data. The map and imagery services where you get the services from. I want to show you the viewers because again, some of you on this call will not have GIS packages to add data to. The nice thing about the viewer is that it's put into a web mapping, a website type environment, and that when you open it, all right, so it is not loading, but it's not Emily's fault because I just loaded this before our presentation. It is our network's fault. But the nice thing about the viewer is that without GIS, you can take a look at the imagery and scale it up fully. Let me
Carl, we do have an update in the works for that viewer, so
okay.
Well, that's another topic for another presentation.
Okay. Let me get back to screen 2. So viewers are good if you don't have a GIS or you just want to open your phone up and see data. Services are good if you want to integrate into your desktop or your ArcGIS Online environment. And downloads are important if you want to access the data directly and you have specific needs on your local GIS, like analysis or something. Okay. I mentioned all those things. Here, I have a screenshot of what the viewer looks like. The advanced viewer is really nice because it gives you most of the environmental data across the state in imagery. So if you work for a land trust or something, you don't have your own GIS data, you can use the advanced viewer to zoom in with the new imagery all the way down and see the details of your local parcels and communities. The aerial imagery is in the services section, and I want very critically, When you hit the plus button, you're going to look for this server URL, and this URL is the direction, the internet direction that you use to point towards the imagery, and I'll show you how to do that. This is the tab used, the data map and imagery services. This one though is critical, and this gets you your imagery service in your application. All right, so let's go through a few different softwares and some basic information on how to access the data. So I'm going to break this into people who have paid for products and people who don't. If you have the ESRI products, and probably a large majority of you, maybe not all of you, have them, you can load this into ArcGIS Online and consume it there. If you have a Pro desktop, you can add the data there, and you can also use this data within a instant app or experience type builder app if you want to build it and then consume it. There may be a few engineers or surveyors who use AutoCAD and MicroStation here. ESRI, there's an ESRI plugin for both of them. And then there's the web WMS, which is that Open Geospatial Consortium standard, which Emily has access to. You can use that WMS URL directly in the AutoCAD and MicroStation to add the new imagery. So you have the things that cost you money through proprietary software, then you have the free stuff. QGIS, which is this one, is available for free. It is a enterprise grade geospatial processing software. It is a worthy competitor to ArcGIS Pro if you haven't used it. It can consume both WMSs and the imagery services, the imagery services being from ESRI. The WMS is the open source equivalent. And then finally, you have a little GIS application called Leaflet that a Ukrainian built 7 or 8 years ago. And with a very small number of R Python code lines, you can actually consume it in a Jupyter Notebooks type format. So some of you may be like the more the data scientist types, and you can actually consume this imagery through there. So if you're going to view your dynamic imagery service, that is the imagery service from Emily, you're going to use this all-important URL here, the internet address. And importantly, this is a dynamic imagery service right now and not a cacher. So what that means is that it's built with calls made to Emily's server. It's built there and on the fly. Soon we will have the final cache service where everything, all those tiles we saw, all those layers will all be pre-built. And so when you call that location, that is all ready to go, and they should be very fast. Emily has kindly provided a bunch of instructions for the ArcGIS Online, so please look at those if you need help, but it's very simple add layer type functionality. If you're working ArcGIS Pro, all you do is add data through the path, and that's in the standard location for adding any data. And you just add the path and automatically picks your service. You add it, goes to into the GIS, and hopefully I'll show you that at the end. I wanted to mention too that there's a REST service directory, and if you go to this, if you double click on this in the website, you get this, okay? And this is basically a lot of the back-end technical information that describes the layer. There's things like extent, there's some critical metadata type information here. You got some additional functionality accessing other parts of the ESRI world, but this square right here is really critical. This is where you can access that WMS web service, which you will use for your open source data. So when if you go in there, and I gave you an example here, you'll see this URL It all looks the same except for this last 7 or 8 characters. What you want to do is look for the URL that says WMS server, and that's the URL that you capture to add to your open source product or your CAD package when you want to have the imagery service added. Since we haven't looked at the software application ArcGIS Pro yet, I just wanted to show you what it looks like before and after you add. You get the imagery. The higher resolution imagery is on the right, and the lower imagery is on the ones on the left. It drops in geographic space, and the beautiful thing is, because it's tiled by the level, you can zoom all the way down to basically 3-inch pixels and back up to the level of the entire state. So you have all that scale flexibility in the URL that you have in an old style GIS desktop application. I'd mentioned QGIS, and if you haven't used this, this is a worthy competitor to ArcGIS Pro. It's absolutely free. They have a version called Long Term for Windows, and what that is a stable enterprise version. This is something that corporations use in-house. It's got all the same stuff as ArcGIS Pro, maybe, and some more. You have Python automation capabilities. So if you haven't used that before, I highly recommend you testing it out, but it allows you to do a free download and use the imagery and data we have without additional cost. Here's a little screenshot about how you do that. You have a layer area here on the left that always shows up when you open it. You have something called ArcGIS REST server, and then you just drop it into the URL, and with that, it loads up your image in geographic space, and then you can add whatever else afterwards if you want to layer it in, like parcels or something. And then I wanted to mention R and Leaflet. This is a slightly different method, and many of you may not have used this before, but if you're a scripting person or you don't have money and you use Jupyter Notebooks, this is a useful tool. Leaflet is a very light baby GIS, but it uses its add WMS tiles command or tool, and as long as you've got the URL layer named, you can add it, and you can then see it in your Jupyter Notebooks. So with not that much code, you can freely access the imagery data within Jupyter Notebooks. So what can you do with them? Well, you integrate them into your GIS applications. We've been having this discussion about projections recently at the state about whether data should all be in state plane or should some of it be in Web Mercator. It gets a little wonky, but the beautiful thing about these services is that they can drop into your web application, and you can combine them with other types of vector data and quickly spin up things like web mapping tools or different kinds of web services. You can put them in other places. You can also consume them and use them with the other data. Some of the things you can do with the imagery, you have something called an image service layer in your ArcGIS Pro, and what you can do is reorganize the data by channel or band, and then also change the way the imagery is viewed using stretch type. And hopefully I can show you that in a moment. I see we're getting a little low on time. And then you could do some of the similar functionality in AGL if you use the image display settings, where you can control the stretch. The stretch allows you to see different image with different priorities about certain things like water or buildings or trees. That's a standard remote sensing technique. And then finally, we very shortly are going to have elevation data, which will be delivered in the same way as a imagery service. And there are a variety of downstream products that you can potentially do with those, things like hillshades, orientation, and then various kinds of hydro and geomorphologic tools. So with that, I've ended the slide deck. should I try to show people real quick what Pro looks like, or do you want to go to questions?
Carl, what would you think about going to questions and then doing the demo after that? And if people can stay on, they can watch, but if they need to jump off, we have a little time for questions.
Okay, that makes sense.
Would that be good? Okay, if there are questions, we can still see your screen there, Carl, if you're getting Pro ready.
All right.
If there are questions, if you could put them in the chat or the Q&A box, that would be great. What is the ETA on the building footprints deliverable and to be available?
We're actually doing a double check right now on the building footprints. We'll get the final return probably by the end of the month. And if we accept them, then it's a matter of we have to make some kind of a vector service. So it's still going to be probably a month or a month and a half out before it's available as a beta service. For those people who are interested in getting data for themselves, we have a few people who already requested building footprints. If they're interested in getting a download, they can send me an email, and I'll be happy to try accommodate them through a USB drive or some kind of a FTP sharing service.
Thanks. Are there any other questions about image services in general? They have a lot of capabilities once you add them to the software beyond just like a picture. You can change bands, you can change, like Carl mentioned, the stretch, apply different functions to look at different band combinations like NDVI to show vegetation and a bunch of different things like that. So if you haven't tried connecting to the image services and trying some of those out, I encourage it. Here's a question: is the new imagery usable through ArcMap 10.8.1? Yes, you can connect to image services in ArcMap with the same concept as ArcPro. The actual clicks are a little bit different, but Richard, if you get stuck on that, feel free to reach out and we can help you with those steps. But you certainly can add services and servers to ArcMap the same as ArcPro and QGIS. Here's a question: how will the 3D buildings be delivered?
That's a good question. It's good probably as a service. And what the most efficient format will be. We have to determine what's the most effective format to be consumed, and that is something we're working on right now. But again, it'll be some kind of web service. Which format it is in is going to be determined after we do some testing.
Yeah, so to clarify, the image services will be the aerial imagery, obviously, and the raster-based elevation, so the DEM and the things that come from that, like hillshade and such. The other data sets, the buildings, the contours, those are vector data sets, and those will be coming not as image services, they're not imagery, through the GIS office and the geodata portal.
Yeah, I will just add, they're likely to be feature services of some kind, and the 3D buildings in particular will likely be a scene layer, which is kind of like the Esri nomenclature for a 3D object. But there is some testing to be done on how precisely those will be, and we will definitely kind of let everybody know what the kind of ins and outs of like how you would consume those are once we actually produce them. So stay tuned on that one for some additional details, but we will be making them available via the web, but in special instances for like specific projects, we can help you out with a physical drive or a download.
And we mentioned at the beginning about training. One of the trainings we'll definitely have is we're definitely going to have a training of at least one and maybe even two on how to use the various 3D data sets, access them and use them, because it really is a kind of a different set of tools in the 2D world. And so we'll be providing that training later in the fall or early winter.
Okay, we have a few questions coming in, which is great. What is the relationship between the parcel data and the survey data?
I can answer that one. So surveys are performed at the request of a particular property owner or on a project basis, and they are submitted to town clerk's offices. And the the parcel data is usually digitized from a survey, especially an A2 class survey, which is one of the more precise versions of it. That work is typically done at the municipal level in the state of Connecticut, because that is where all of the assessors are, and so that's where in some few cases, so the COGS kind of help help their respective towns digitize that data. But the relationship is that the survey is the kind of source of truth for the geometry. And that is kind of where the information comes from, where that is then later digitized to create the parcel data.
And I should say the survey is the legal description.
That too.
And the digital version you see in the GIS can be exactly the same, but it is not the survey is actually a legal document as well.
Thanks. With respect to LiDAR, will there be a way to identify old house foundations and other potential historic features? So you want
Let's
to
see.
do that one?
I will.
Answer is yes.
Yeah. Yeah, you can really see it already in the 2016 LiDAR DEM, the elevation model, the raster-based one, especially the hillshade. You really can see them already. So it will be the same, even a little better, because it's a slightly better, higher pixel resolution, so more detail. So
let me add something else. You can actually the resolution is substantially better than the last cycle, and so we actually are picking up things on the ground like individual boulders. So if you can see an individual boulder, then you can see an old stone foundation, provided it's not covered by something else. What was the second half of that question?
that was it. Can
And
you
other
identify?
potential historic features. So
Oh,
one
yeah.
of the other things that we've seen anecdotally that I will add to that is we have actually been seeing like rock walls in the middle of the woods and the contours as we've been evaluating them. So it's not just in the DEM. These are kind of like these kinds of features and things have been kind of proliferating throughout all aspects of the data, even to the point that the vendor had to produce an algorithm to remove fallen trees from the ground plane. So there's a lot of detail in this data, and the thing I always tell a lot of people with this data is, as good as you think it is, it's probably actually better.
And as someone with an environmental background, I'm really excited to see. You can actually see, especially in the Northwest Hills, were places where there weren't trees in the 1800s, and so there was probably a lot of erosion going on. It got covered by forest, but you can actually see the old remnant channels in the from the LiDAR in the ground plane, which is really pretty cool, especially if you're doing work like wetland delineation or other kinds of stream channel work.
Yeah, just to reiterate, our previous LiDAR had an average or a minimum of 2 points per square meter, and this has a minimum of 15 and 20 along the coast. So it's a giant increase. The next question is the 2023 ortho data now available? So I have just gotten, in fact, yesterday I got the last drive of the last section, and I'm creating the service. So there is an image service up. It should be considered a draft. I'm also adding in the true orthos, which were delivered later. So they are not all in there yet. So the first thing will be the service, which I'm doing as fast as possible. Once that's finished, we'll do the tiled service. And once we have the DEMs, we will do the data download the way we've done with other data sets. I should mention that the 2023 orthos will be available as a service. And then we also have download as TIFFs and Mr. SID 3s and Mr. SID 4s. And eventually we will have the same townwide mosaics in Mr. SID format as we've had in the past. So that's coming. The first thing is the service, and we're getting close. Will the 2023 LiDAR services include hillshades, and can multi-directional be added? Yes, there'll be a hillshade. yes, we currently have 2 directions on the 2016 with functions built in. That's one of the things you can do with image services. So we will at least do that again. And I think there's already a help page about that, but I can make sure we stress that about how you can add different directions either in your own GIS or by applying pre-built functions to the services. Okay, thank you for making this data available. Are there any plans to update the land cover map using this new imagery?
Short answer again is yes, but that is ongoing. We are in conversation with NOAA and working with our vendor to secure additional data to make that possible and enable that work. But that's all I'm comfortable saying at the moment. But it is coming.
I will also say there are products already available, like from Sentinel. You can see on Yes Right Living Atlas. So if you need a good, if not amazing, land cover, there are current products that you can find from other sources that give you a lot of what you're looking for. We're hoping that the land cover that we produce in the near future, provided everything works out, will be particularly high quality for impervious cover mapping, things like driveways, sidewalks, and streets. And that should be, if it all comes together, it should be a very eye-opening product, but we'll wait and see on that.
Someone's requesting that the to add the 2023 ortho to ArcGIS Pro steps, like post a link in the chat. I'm not sure. So yeah, Carrie just added the how to connect with ArcGIS Online. I think if we have a pro one, we can add it. If we don't, we need to create one about how to add the services that, and Carl's going to demo that next, I think, maybe.
Well, when they stop, I'll try. That may be the only demo I'll do along with the imagery service. But if you want to hang on, we'll try that.
Eileen, feel free to email us too, and we can get you those steps. And here's a comment: there are certainly plenty of individual boulders to be seen in Connecticut, and we all know that's definitely the case. Another comment that the 2016 LiDAR has been great for mapping rock walls and foundations in the woods along with old skid roads. So I reiterate, there's a lot that you can see with that data set, and this will be even more so. So here's a question. For land trust, what are the first steps to evaluate raw land for acquisition and then map trails, points of interest, invasives, et cetera, on land trust parcels?
That's a loaded question, but
that might be a good webinar.
You're basically doing GIS a GIS program there. But I would say the first thing is to do is take this imagery and look at your property, and that way you can visually evaluate it. The second thing I would do is I would grab our parcel data set, and then you have all the characteristics of the buildings that are on that parcel, and then you should evaluate, make a rank order evaluation of the qualities you care about to decide where you want to spend your money and the relative cost. If you want to, if anyone wants to talk about that, I'd be happy to get on a call and go through a process. But basically, it's just like it's the GIS version of showing up at a site in a truck and walking around, except instead you gather the data from CT Eco, from Deep, from our imagery, from our LiDAR, and then make an evaluation based on those things.
So while I'll answer that here at CLEAR, this is kind of our job, is to help make all this geospatial data available so people can use it, land trust being one of our main audiences. And so I think we have a couple viewers that might work, but it may be an opportunity for us to help pull these layers together in one place for folks like you. There are many land trusts with the same questions. We also do a lot of work with trail mapping. And so I'd be happy to talk to you or Carrie, who's on, about how CLEAR can help support this. And you don't necessarily have to make your own maps, as that can be kind of a heavy lift for people that are not in the GIS profession. 100% of the time.
Emily, I'm going to
Um,
throw out a question here about this. In your advanced viewer, do you have our parcel data set?
yes. Yep.
Oh, you do. Okay, so the best way to do is actually go to the advanced map viewer and then pick your 3 or 4 critical factors and take a look, start there, I think.
Yeah, but I think this is a great idea that we might be able to help. The advanced viewer has a lot for sure, but we maybe help modify that. So thanks for that comment. And another here, is there anything that we all could use from the audience here, people attending, that comes to mind?
Yeah. So what I will say here is we definitely need your ideas about what you want to hear from us and what your priorities are, what things you care about. This is how we kind of establish our own priorities along with all of the other things that we have to kind of juggle. But definitely a big component of that for us, and part of the reason that we are doing these trainings and outreach and these webinars, is because we do want to hear from all of the stakeholders wherever they are, and we need your ideas to do so. So we definitely want to hear what you want to hear from us, what like what things you want to learn about, what things you want to be able to do, these kinds of projects, like the land trust about evaluation tool, like that's an idea that, like, I think if we think about it, and it's like, if it's achievable, then it's worth it for us to put effort into that and make sure that we can serve all of the community. So I would say that is the thing that we would want to hear from this and any audience.
Thanks, Alfredo. Yeah, feedback and interaction is super valuable for
Yep.
us. And another shout out to that kind of land trust training for land trust volunteers. We hear you. And then a request to send out the chat to all participants. I will work with Carrie and Dave on the tech side and see if we can do that. And if we can, we will. Okay, one last question, and then I think we'll go to the demo. Is there any bathymetry data or layers?
There's
Go
no,
ahead.
there is, I will say this, there is some new nearshore information in the LiDAR and in the imagery that you could potentially extract. We don't have a real bathymetry layer. This is not data that is designed for that. That is something we did some initial exploration on. We're still looking for a source of funding. So the answer is not really, but if you need to get a little bit of information out of the nearshore environment, you might be able to use the imagery and perhaps some of the LiDAR returns for that. But we're talking really shallow, like 3-4 feet max, nothing deeper.
There is a different data collection going on around our tidal marshes, just very specific to them, that includes some topobathy. So if that's something of interest, please reach out and make sure that you know about that. Okay, Carl, do you want to take a few minutes to do a demo we still have quite a few people hanging on that might like to see it.
So yeah, so I put this in the chat, but I'm going to assume that everyone wants to see the ArcGIS Pro and then the imagery service layer. If that's the focus, let me know. If there's something you really care about, also tell me.
Why don't you start with that, and we can take other comments if people have them.
All right, so can you see the ArcGIS Pro interface? Yes? Okay.
Yep, we got it.
So I'm not going to switch screens because that has not gone very well today, but I'm going to go into Emily's site.
Hey, Carl, before you do that, can you just briefly show, like, don't do it, but show the steps you took to get this imagery service into ArcPro?
Oh yeah, I was actually doing that, but I can actually, what I was actually going to do is do the late steps after I grabbed the information.
Okay, great.
So first thing is you go to CT Eco and you go to imagery, map and imagery services.
So we're only seeing your ArcPro right now.
I know, I understand that.
Okay.
The only thing I'm walking through it verbally because I didn't want to switch. I was having problems switching screens.
Oh, gotcha. Okay.
So the key thing was I showed you on the other slide, it said server URL for dynamic image services under 2023 spring. So I'm now going to copy that. And so now everyone's going to see my cursor show up in the on ArcGIS Pro. Everyone can see now I went add data, and it says data from path, and you'll see a little path field, and I'm going to copy and paste that URL I grabbed from the image services at CT Eco and copy it in. And you see it says the service type is ArcGIS server web server. Emily can confirm that in fact it's coming from her office. So we just add it. And now it's calling the server, and it just dropped in. Okay, so now this looks kind of like a static image. And remember, I said each time you touch the cursor, you're making a call back to the server. So just to demonstrate that, I'm gonna scroll into my where my house is in Simsbury, and you'll see that the data is loading in at higher and higher resolutions. That's the different levels of zoom cached in the map tiles coming available. Actually, this case is actually dynamic, isn't it? Not cached, but at each level we're coming in and we're grabbing a new set of information, and you can see we're down now to the parcel level. Now we're at the house level. And now you can see the lines between the highway lines, and so that the resolution is remarkable. You can even see cracks in sidewalks in some places, gutters. So this is that's it. That's all it took, and then you can add back in your your vector data is on top of it, and if you take a look at your vector data, you'll see it's all in the right spots. This happens to be transportation crashes. Here's one in Bloomfield, which I know this is a nasty stretch of road. So this validates the position of the crash on 187 in Bloomfield. So that's pretty straightforward. And let me just quickly show you the image service. You select your image service, and you'll see you get something called image service layer. And if you hit the tab, you get a new set of functionality. One of the things, first basic thing, everyone learns this if you take a remote sensing class on day one, is that you can change the bands. We have 4 bands available. So this is what we call natural image. Now let's look at the near infrared. So we're going to take the red band and we're going to push the near infrared into the red band, into the red channel. And we're going to reorder these, and you're going to see that you get a very different looking image. Sorry, 432, not 431. And we just dropped the blue level out. And what you're seeing in the near infrared is that chlorophyll in particular is very bright in the near infrared. This is flown in the spring, so fresh grass and evergreen is this really brilliant bright red. Buildings are kind of the same through the different bands. And then I'll show you if I can find a little water here. Near infrared is really doesn't reflect much in around water, and so these dark spots here are where water is, and so that's a way of picking out water. And even you can see places where you have some channels, a little bit of water popping up through the dense tree cover. And then just another thing, quickly look at the stretch type. Stretch type basically is how you distribute the pixels. I'll leave it to you to look at the data on your the different types on their own, but basically you either stretch them out in a linear sense, that means you spread them out over a full range, or you use a standard deviation which clips off the high values, like things like light reflecting off of water and stuff. So let me just show you what that looks like. If that changes anything, maybe it won't. All right, let's try one more time.
I think everybody might have just clicked on Carrie's links, Carl.
Oh,
You slowed down.
all right.
I'm not sure.
All right, so this is I use the standard deviation stretch. You can see some of the colors change and some different things popped out. And the max min value, that's a stretch, linear stretch. It's a little flatter. This is not very spectacular, and I unfortunately don't have a great example here, but it does allow you to see different features in the imagery in different locations, and it's a very effective way for feature identification in some spots. So, all right, with that, I will stop sharing unless there's something specific people want to see, and we can wrap things up.
Yes, I think because we're over time, we probably will wrap things up. But if you do have questions, please email us at clear@uconn.edu and I'll make sure the right person on the team gets it. And these links are still in the chat as part of this webinar. Once again, this recording will be posted in the Clear webinar library along with a PDF version of the slides. And we hope to see you at future webinars. And thank you, Alfredo and Carl, for presenting today.
Thank you, Emily. Thank you for participating to the audience.
Yes.